Hello and welcome to week 9. In last week we were discussing about 3-spool configuration. Then we started discussing about the mixed flow configuration, and in mixed flow configuration we have discussed our engine without afterburner and with afterburner. We were also discussing what are the advantages, what are the challenges for such kind of engines. Then we tried to solve the numerical in order to understand the effect of various cycle parameters on the performance of the engine. Now, this week it is really very interesting week, where we will be discussing what all are the recent advances in turbofan engines over last 20-25 years, where we will be discussing very first with aft fan turbofan engine. We will be discussing about the recent advances in aircraft engines, both for commercial as well as for military engines. We will be discussing specifically in terms of variable cycle engine, hybrid engine. Then we will be discussing about the turbofan engine with intercooler and regeneration, and we will be discussing what all are the effect of various cycle parameters on say engine performance. So, let us start with say very first, this all are the engines what we already have discussed, which includes single spool configuration, which includes 2-spool configuration, 3-spool configuration with the forward fan. We have discussed about the forward fan mixed flow configuration, where we were discussing about without afterburner case and with afterburner case, and we found this has application in terms of special military purposes. So, let us move ahead in sense of what all we know. Say this is representing our 2-spool configuration, where the compressor that will be rotated by HP turbine and the fan that will be rotated by LP turbine. We have seen other configuration also, where we have discussed say LP turbine, that is what will be rotating fan as well as say LP compressor, and HP turbine, that is what was rotating say HP compressor. And what all discussions we have done up till now, we were focusing mainly on say thermal propulsion and say maybe thermopropulsive efficiency. We were discussing in terms of say specific fuel consumption, something we have discussed in terms of emission, noise, compactness and weight consideration, safety, cost. So, these all are the criteria when we are selecting our turbofan engine for the application for both commercial as well as say military purpose. Now, let us look at one configuration here in terms of we are looking for compactness and weight. So, we know when we are incorporating different kind of configuration, what all we have discussed, where we have one of the criteria as weight. Again, just look at this engine. Can you find any possibility in order to reduce the weight of this engine? Let us see, suppose if I will be giving you one of the hint here. In this case, say we have 2-spool configuration here, in which we are having say inner spool or LP spool, that is what will be rotating the say our fan. Outer spool, that is what is my HP spool, that is what will be rotating the compressor. Now, if we look at carefully the length of the spool, here in the case of LP spool it is higher. We can say it will be having larger diameter also, and that is the reason why it will be having the weight also. Can we think something in which we will be trying to omitting this spool itself? You will say, what is this? How do we do it? Let us say, suppose if I consider I will be removing one of this spool, that is what I say as one of the alternative. Why we want to do this part? Because we want to reduce the weight, and the question is why we want to reduce this weight? Because we want to reduce the drag. And why we are looking for the reduction in drag? It says that is what is to improve or lower the specific fuel consumption. So, you can say that can be one of the configuration for our future engine. Let us look at how do we do it. Okay. So, here in this case, if you look at what we have, you can say we are having this as our core engine, where my HP turbine, that is what will be rotating the compressor, and I will be having my say LP turbine, that is what will be used to rotate the fan, but this fan, it is placed on say aft side, it has been placed on the rear side. Okay. So, here if we look at carefully, you can say we have tried to remove the shaft of this spool. We are able to reduce the length required for this engine. We are able to reduce the weight of this engine. Okay. So, this you will say, what is this? Do we have this kind of configuration possible? So, here it is an example. Here if we look at, this is representing the cut section of GECF 700. So, here in this case, if we look at, this is the HP turbine, that is what is used to rotate all compressor stages, and on the later stage we will be having say our LP turbine. And if you look at carefully, this LP turbine, that is what is connected with the fan blades. So, like this turbine itself, and it will be acting like the stand for the placement, or the disc for the placement of fan. Yes, just look at. So, like we are able to remove the requirement of bearing also. Okay. So, this is the kind of configuration what we will be discussing now. Okay. So, I am sure you are getting what we want to convey here. We will see what all are the advantages and what all are the challenges for this kind of configuration. But at this moment, you can say this seems to be very promising kind of configuration. So, let us try to understand, say this all we have discussed. Now, we will be discussing about the aft fan configuration. So, here you can see this is fitted with the aircraft on the aft side, you can say it is fuselage install kind of configuration. Similarly, here also on the aft side we will be having say engine. This is same as what we are discussing in terms of say GECF 700 or GCJ 805. So, this kind of engines they were existing, even as on today also these engines are existing. Okay. So, based on that, let us put the numbers here. Suppose if I consider this is representing free stream condition, here we are having say inlet duct, then we have our compressor, combustion chamber, we can say HP turbine, LP turbine, and that LP turbine you can see that is what is used to rotate this fan. And here in this case we are having say exit, two nozzles, we will be having one nozzle, that is what will be from fan, and second nozzle, that is what will be from my hot section, or we can say the core exit nozzle. Can we try to plot the TS diagram for this kind of configuration? Let us look at, say this is my free stream condition. Here we are having this as our intake, then we are having say compressor, that is what will be raising the pressure from P02 to P03. After that we are having say combustion chamber, and this combustion chamber actual process we are representing from say constant pressure line, and that is what will be raising the temperature from T03 to T04. Then we have our HP turbine, that is represented by say process 4 to 5. We have our LP turbine, that is what we are representing from process 5 to 6, and we have our exit nozzle from the core engine, and that is represented from P06 to P7. Now, here in this case if we look at carefully, we are having fan also, and this fan, that is what will be sucking the air from the atmosphere. Here if you look at carefully, this fan it is placed on the rear side, that is what will be sucking the air from the atmosphere. Here in this case we are having little different configuration, where this is ducted one. So, in that case what will happen, this fan, that is what will be raising the pressure from say 2 to say 8 or infinity to 9. This is my exit pressure, and here if we look at, this is representing my fan nozzle. I am sure you got the idea about what we all discussing about say TS diagram for this kind of configuration. Okay. So, do not get confused in terms of how exactly this is been placed. You can say it is from infinity to say 8, that is what is my suction process, or that is what is my intake. So, you will be having two intakes, one it is for core engine, and second intake if you look at, that is what will be for the fan. Suppose if I consider this kind of configuration where we are having say one intake, that is what is the main intake, and inner side also we will be having other intake. Okay. So, here for this configuration, let us try to look at what all the benefits we are getting. Very first it says we are able to reduce the noise. The problem here, or what all solution we have, since we are putting our fan on the aft side, and that is the reason why we are having it is away from the ground side, and that is what will be reducing the community noise, which is because of during the operation of say takeoff or landing. So, it will be acting like a shielding of my noise, that is one thing. Secondly, at the exit if we look at carefully, we will be having core exit, that is what will be coming out, and it will be covered with my fan exit, and that is what will be acting like a noise suppression device. So, it says like we are able to address the issue, that is what is related with the noise. At the same time it says it is improving the aerodynamic configuration. It says rear mounting, that will give the aerodynamic efficiency, because we will be having optimization of the flow path. Okay. At the same time when we are integrating that with the wing or say airframe, that is what will be reducing the drag, and that will be improving the overall performance of the aircraft. So, here if we look at carefully, we have installed this kind of engine on the aft side on the fuselage. So, you can say the placement of this engine is equally important, and the aerodynamist he need to take care of, or she need to take care of this all configuration. Okay. Then it says it is increasing the bypass ratio. If we look at carefully, since we are putting that say on the aft side, so my core engine dimension, that is what will be reducing. The idea here is we are able to rotate our core engine at the high speed, and that is the reason why we are able to reduce the size of the engine. Okay. At the same time we can put say larger size fan, that is what will be improving the bypass ratio, and this is helping us in terms of improvement of fuel economy. At the same time it is reducing the specific fuel consumption, and it is more environmental friendly and cost effective. It enhances safety also, because like foreign object damage, the chances for this kind of foreign object damage to this engine during takeoff and landing are less, since we are having our fan on the back side. Okay. Same way we are able to reduce the weight, because my weight distribution, that is what is very important in terms of my aircraft balancing, okay, and say aircraft aerodynamic characteristics. At the same time what we have done, we have removed our LP pressure long spool, that is what will lead to reduce the overall weight of the engine. Okay. So, that is also putting additional benefit in terms of reduction of our drag. Let us see what all are the challenges. As we say, when we are putting this rear mounted fans, that is what will be increasing the complexity in terms of aerodynamics, because we will be having interaction of wing, we will be having say other aircraft component, it may be coming in the flow path of this engine. That is what will be putting the design for this configuration to be very challenging. At the same time we need to take care of flow separation, we need to be careful about say increased drag configuration. So, aerodynamically putting this kind of engine or say engine installation, engine integration with the aircraft, that required careful consideration. Same way structural challenge also will be coming, because we will be having say introduction of this engine that will alter the weight distribution. Say we have seen these engines we are putting on say aft side, on the rear side, At the same time, reinforcement is also equally important, because when we are fitting this engine on the fuselage, we need to be very careful in terms of placement, because it will be increasing the load as well as stresses. Now, very challenging part for any engine which we will be fitting on say fuselage, it is with the center of gravity. We are putting this engine on the rear side, that is what will be shifting the CG, and that is the reason why it is putting challenges in terms of stability and the controls. Okay, so, proper balancing and the control that may be required for all the phases of our flight. Okay. Then it says it will increase the weight, because additional support structure, that is what is necessary in this configuration. So, other than engine weight, we will need to put say additional components for the fixing of this engine, and that is what will be increasing the weight. So, just do not get contradict with what previously we have discussed. Previously, in terms of advantages, we are talking about reduction of the weight of the engine. Here we are discussing about say overall weight because of engine. At the same time, since we have kept our fan on the rear side, so maintenance and the accessibility, it is little issue, and that is what will lead to increase the maintenance cost as well as time. At the same time, if we look at carefully, as we have discussed, we are having say placement of the fan on the rear side, and that too it is placed on say turbine blade. That is also very challenging part. We will see what is the challenge for that. And it is having say limited existence of the infrastructure. Say almost all engines what we are using at this moment, they all are say front mounted fans. So, if we will be using this kind of configuration for the future, then we need to change the infrastructure for the airport. At the same time, ground handling procedure also, maintenance facility also we need to improve, and that is what will be costly as well as time consuming process. And that is the reason why the popularity of this engine, it was not that big. If you look at the integration, as I was discussing, we are having the integration, that is what is a big challenge. Then we have challenge in terms of selection of the material, because what fan we are discussing, that requires special kind of aerodynamic, thermodynamic and structural consideration. If you look at carefully, since my all say fan blades, they are being placed on say our LP turbine disc. Suppose if we are using similar kind of material, then it will increase the cost of the material as well as it will increase the weight of the fan. At the same time, since the increase of weight of the fan, it will be increasing the weight of the engine. Suppose if we think of using dissimilar material, then in case of some metallurgical issues, that will give the catastrophic failure of the engine, and that is the reason why the airline companies, they are little hesitant to move towards such kind of engine to be used for their aircrafts. And as we say, like we are having say technological challenge, because this required always the proof in terms of risk, in terms of potential application benefit, in terms of say your manufacturer as well as airline companies. And that is the reason why the popularity of this kind of configuration, it was not that big. But GE, they have tried their best in order to improve, in order to address all these challenges. Okay. So, let us move towards the next. So, as this dedicated week, it is for say recent advances in say aero engines. So, just look at here, if we look at, this is a good compilation of data by Rolls. It says like we are having three main variants, that is corporate or say regional aircraft, middle of the market or we can say medium range, and here this is what is say large or wide body aircrafts. So, here we are having say application in terms of say regional transport aircraft, we will be having business aircrafts, we will be having say like new corporate aircrafts, they will be coming in this range. Now, if we move towards the middle market, say A320, 737, they all are existing at this moment and they are using CFM LEAP Pratt & Whitney Gear Turbofan engine, V2500, and we have discussed about all these engines. They are working absolutely fine, they are very efficient, and they are able to address what all are the requirement by say airline company as well as by the regulatory body. So you can say this is what we are discussing in terms of 2000 to say 2020 or 2023. Here in this case, if we look at the large aircraft, there we are using say Trent 1000, GenX, Trent XBW, GE90, Pratt & Whitney 4000, Trent 800. It says very soon these aircrafts they will be looking for the replacement of the engine because they are changing their capacity, that is one. Secondly, they need to meet the regulations that is being imposed by say regulatory body, and those until and unless they will satisfy those regulation, they are not permitted to land or take off their aircraft from that particular say airport. And that is the reason why whole research and development activity, that is what has been going on. So here if we look at, it says these are the future engines, and these future engines you can say it is advanced turbofan engine, advanced turboprop engine, ultra high bypass ratio turbofan, open rotor, large engines. We are also moving towards a supersonic business jets. Now you can say these all are with the target of 2020 and 2035. So lot of work, that's what has been going on for last 2 decades in order to address the issues, and that's what will be meeting with the requirement that our target with say 2035 and beyond. Also we need to think of now, from now onwards. So almost all engine manufacturing companies, they are working in order to address the issues related to 2020, 2035, 2050. Okay. So let's see what all are the requirements. So there is a body called ACARE, it is Advisory Council for Aeronautical Research in Europe. They are identifying the need of aeronautical industries, and they have given their targets in 2005 saying like Vision 2020, and their objectives they have defined as reducing the fuel consumption and CO2 emission by 50% with 20% for the engine. Second target they have given, that's reduction of say pursued external noise by 50% with 6 decibel per operation for engine alone. Next it is to reduce say NOx by 80% with 60 to 80% for the engine alone. So here if you look at regulatory body, they are very specific in terms of emission, in terms of noise, and in terms of fuel economy, and that's what has given the boost up in terms of research and development activities to be carried out for say future engines. So you can say that's what was as a Vision 2020. Now again they are started working for the future engines also, and that's what we are targeting for 2035, and very soon we will be having vision say 2050. And if you are reading the articles, if you are going through say newspaper, then you will find we are talking about net zero, carbon zero by 2050. That is also the requirement for the aero industries. Let's see what all are they. So these are the major concerns, that's what was given by ACARE. Now what all we were concerned about in the past, they are related with the weight, they are related with the drag, we were looking for say high speed, then we were concerned about the cost, then slowly we started discussing about the specific fuel consumption, noise emission that has come into the picture, then we were discussing about the reliability, safety, all those aspects. Then slowly we started thinking in terms of thermal efficiency and propulsive efficiency. The reason is we are concerned with the specific fuel consumption. Now in order to address that, we realize if we want to improve the thermal efficiency of the cycle of the gas turbine engine, then we need to improve the component efficiency. It covers all components, okay, and secondly, that is what is turbine inlet temperature or the turbine entry temperature. So, we need to move it higher turbine entry temperature, that is what will lead to improve the thermal efficiency. Then there was a target, it says you improve the propulsive efficiency, and if you recall, we were discussing in order to improve the propulsive efficiency, we need to increase the bypass ratio. So, these things they are known to you. Till now we were not concerned, we were not discussing anything in terms of noise as well as the emission issue. Okay. So, let us target that part. Suppose if I consider I want to address say CO2 emission. Now, in order to address this CO2 emission, we need to take care of the fuel burn, because it is directly in proportion with the fuel burn. So, we need to reduce that, and in order to reduce that we need to have certain criteria. What it says, suppose if I want to improve say my fuel economy, there are two ways, that is what we have discussed up till now. One, it is to reduce the weight and the size of the engine, you can understand what we mean by that, and second, it says reduce the engine specific fuel consumption. So, these two that will be helping in order to address the CO2 emission case. So, in order to reduce say weight and size of the engine, what we need to do is we need to lower the aircraft maximum takeoff weight. Okay. So, you can say in this is what is giving the idea in terms of say aerodynamics of your aircraft. Okay. Second, reduce the thrust requirement for the given engine for say particular lift to drag ratio. Yes. Then it says reduce the size. The size what we are discussing, this size is with the engine, nacelle diameter and the length of the engine, because if we are addressing that by reducing the nacelle drag, we can able to reduce the thrust requirement, because we are able to reduce the drag. Second, that is what is related with the improvement or the reduction in say specific fuel consumption, and that is what can be addressed by improving propulsive efficiency and thermal efficiency of the cycle. And in order to improve that, we need to look at each component level efficiency, because if we are able to reduce the losses, we are able to improve the efficiency, and that is what will lead to reduce the specific fuel consumption. So, now let us look at different targets. Very first, we will be taking as a propulsive efficiency, for which our target is to improve the propulsive efficiency and hence engine specific fuel consumption for given thermal efficiency. You can say, suppose if I target to improve the propulsive efficiency. Okay. So, this can be addressed by designing the engine to meet low specific thrust. So, what we mean by specific thrust, that is what is in terms of net thrust divided by fan inlet mass flow rate. What it indicates, in order to get this lower specific thrust, we need to increase the mass flow rate. That is what is required, a larger size fan or larger diameter fan for particular thrust. This will lead to increase the engine weight, and that will be neglecting the benefit in terms of improvement of specific fuel consumption. So, what it says, in order to improve the propulsive efficiency at constant weight, then we need to think in terms of weight reduction technology. Just try to understand what all we are discussing. Okay. So, here in this case we need to have some weight reduction technology such as lightweight fan design and new soft material. That is what will lead to reduce the weight of the engine, and that will be helping us in order to improve the propulsive efficiency, and at the same time it will be improving specific fuel consumption. Second, it says increasing say bypass ratio, that is what will be giving the issue with the speed mismatch between fan and low pressure turbine. We have discussed this part and we have got the solution also. We have discussed about gear turbofan engine. What it says, by introduction of gearbox, we can elevate, we can minimize the problem and we can meet with the optimum speed requirement. Hence, the engine weight and improvement of the efficiency can be achieved. So, it says now we are moving towards the improvement of propulsive efficiency, where we are looking for say high bypass ratio engine, and in high bypass ratio engine also we are looking for special kind of materials, and we are looking for special kind of say speed management system. Let us look at this. So, here if we look at this is representing fan diameter, or we can say propulsive efficiency, and on y axis it is representing the fuel burn and CO2 emission. So, here if we look at during 80s, our target always is to improve the specific fuel consumption, improve in the sense to minimize the specific fuel consumption, and it says we are able to improve it by increasing the fan diameter, or we can say by increasing the bypass ratio. But at the same time, when we are moving downside on the next generation aircraft, what is happening? We are facing the difficulty in terms of weight, we are facing the difficulty in terms of drag. Okay. So, now these are the challenges for our future engines. Now, when we are increasing the fan diameter, we are able to minimize the rotational speed. That is what will lead to improve your noise emission. We are able to reduce the noise emission. So, it says in order to have the improvement of fuel burn and noise, we need to have lightweight fan and LP turbine. We are looking for lightweight and low drag nacelle, fan and LP turbine efficiency that need to be improved. Okay. Now, let us target with the second case. It is say related with the thermal efficiency. What we mean by this thermal efficiency? We say we want to improve the thermal efficiency and hence engine specific fuel consumption at particular propulsive efficiency. So, we have discussed all these aspects in past 8 weeks. In order to improve the thermal efficiency, we have one way, it is to increase the overall pressure ratio. Suppose say if you are increasing say overall pressure ratio, then we are having say improvement, or it will give the optimal level of turbine entry temperature for particular thermal efficiency. Suppose if you are looking for the fixed specific thrust, and if we increase the turbine entry temperature, that will result to smaller core and higher engine bypass ratio engine, and that is what will be helping us in terms of achieving the thermal efficiency. So, what all we are discussing at this moment, that is what is been implemented. So, in all these 5 lectures we will be targeting all these aspects what we are discussing. We are making the background first, and then after we will be discussing how the engine manufacturing company, engine design company, engine research company they are working on. Okay. So, it says if we are improving the overall pressure ratio further than the current engine, then it will be putting the limitation in terms of say high pressure compressor delivery temperature at the takeoff condition. So, just realize the case, we cannot increase the overall pressure ratio to very high number, because we know when we are moving towards very high pressure ratio, at the same time my turbine entry temperature, suppose say it is lower, then it is a violation of our thermodynamics. Okay. We have discussed these aspects when I was discussing about say our turbojet engine class. Okay. So, just revisit that class. Same way, increasing the turbine entry temperature, that also is the other way. Now, when we are increasing say turbine entry temperature, there we are having our issue in terms of material temperature, and that is what is a big challenge in terms of takeoff as well as top of the climb. So, now if we are increasing say turbine entry temperature, it means we need to go with say specialized cooling technology, cooling strategies we need to address with, and that is what will be helping us in order to improve the thermal efficiency. Now, let us look at what all people they are working at this moment. So, here if we look at, this is my direct drive configuration, where we are having say lightweight fan, we are having say integration, we are having all components, they are very efficient. Now, in order to reduce my specific fuel consumption, we have moved towards say ultra high bypass ratio engine. Ultra high bypass, you can say where my diameter of the fan it is larger, and if you compare the size of my core, that is what is reducing. Same way we are moving towards a gear turbofan engine, and in recent era people they are working about the open fan configuration. At the same time, if you look at here, this is what is giving the indication, say we will be moving toward this technology in order to improve the specific fuel consumption, but installation, that is what is a big issue, technical risk, that is what is coming with. And if you look at our bypass ratio, that is what is increasing a lot. Okay. Here this is what is representing my cruise Mach number configuration, and in relation with the overall efficiency. If we look at carefully, this is representing the band for this turbofan engine, where we are having our thermal efficiency to be higher, but at the same time propulsive efficiency is little poor. If we look at here, this is representing turboprop engine, where we have our limitation in terms of cruise Mach number or flying Mach number. And the ongoing research, that is what is indicating this as a region where we are having, say, higher core efficiency, as well as it is giving the indication of improvement of propulsive efficiency. Okay. Now, let us target with the CO2 and NOx emission. If we look at NOx emission as we have discussed, then that is what is related with the specific fuel consumption, and we can say in order to reduce that case, we need to go with the increase of overall pressure ratio and turbine entry temperature. That is what will be increasing the NOx emission, because we are moving towards the high flame temperature. So, now in order to address the issue in terms of reduction of CO2, we have options, but at the same time we have emission of NOx. That is what is required. A special kind of combustor need to be designed in order to handle, say, low air to fuel air ratio. Okay. That is what is required, the film cooling, and at the same time we will be having, say, temperature traverse quality, that is what will get deteriorate. So, now the requirement of CO2 and NOx emission, that is also a major criteria, and we are talking about net zero carbon emission challenge. We say that as a vision 2050. What it says, like current projections estimate that demand for this air passenger journey in 2050 that could exceed by 10 billion, and the expected 2021 to 2050 carbon emission on the business and usual trajectory, that will be in the range of 21.2 gigatons of CO2. So, now this is what is a major concern, and so you can say when we say this as our major concern, that means we need to move towards a development of engines, we need to modify our engines, existing engines, we need to think of new innovative way to address all these aspects. Okay. So, we will be discussing all these aspects in coming lectures. Stay connected in this all lectures, because these are very important, and that is what will be giving you idea in terms of how you as a person need to think of how you can be a contributor to the society, and how you can have your good placement or say job opportunity, both in terms of say development activity, in terms of research activity, in terms of manufacturing activity. So, here we are stopping with this session. We will be discussing further in next class. Thank you very much.